Okay, for this lesson, we are going to model direct variation. When you are modeling direct variation, you're going to use the equation y equals ax. And when you think about direct variation, you have to assume that a is always going to be not 0. It has to be an actual number. When it's written in this form, y equals ax, the letter a, that's going to be considered your constant of variation. And when you have it written like this, you can look at it saying that y varies directly with x because you have y on the outside of the equal sign. Okay, so most of what you're going to be doing in this lesson is rearranging it for y. Okay? So let's look at example 1. First, they want us to tell whether it has direct variation, and if so, identify the constant. So they've given you an equation, 2x minus 3y equals 0. So the first thing we're going to do is solve for y. Well, what's my first step to get y by itself? Yep, I subtract the 2x. So I'm left with negative 3y equals negative 2x. Now what's my next step to get y by itself? Divide by negative 3. A negative divided by a negative is a positive.
2/3.
Yep, so I'm left with 2/3 x. Is this written in direct variation form?
No.
Are you sure?
Yeah.
Yes, it is. You can have a fraction here. The only rule is you can't have a 0 here. So this is considered direct variation. The second question they ask is, what's the constant? Well, the constant is whatever is in the place value of a. So in this case, the constant equals 2/3. Okay? All right, let's look at the next one. Example 1, but this is letter B. We have negative x plus y equals 4. So we got to solve for y, so I'm going to add the x. So I get y equals x plus 4, correct? Is that in direct variation? No, because you have this random plus 4 at the end. If you ever have, a plus 4 or a minus 4 or anything on the end, automatically you know it's not going to work. So you just say not direct variation. Okay, I'm going to do a few more examples from the guided practice. You can choose whether you're going to put these in your journals. Negative x plus y equals 1. Can you look at that and tell me without solving it if this is going to be direct variation or not? Geraldi thinks it won't be. Do you guys agree with him? Yeah, because once I solve it, I'm going to have this random plus 1 at the end. So I can look at that and say not direct variation. I should put DV. So let's look at number 2. 2x plus y equals 0. So far it looks okay, right? So let's move the 2x. So I get y equals negative 2x. Is that direct variation?
Yeah.
Yes. So yes, it is direct variation. And what is its constant?
Negative 2.
Very good. Negative 2.
You have to tell it.
If it asks you for it. In this case, it said identify the constant. Any questions on this? All right, I feel like you got it. So now let's look at what a direct variation graph would look like. It's going to be a linear equation, so it'll be in slope-intercept form when you solve it. You'll notice that it always has what for the y-intercept? Look at this equation. Where's my y-intercept here? It would be plus 0, right? So it's always going to go through 0, 0, the origin, when you graph these. Always. So if I have, this is example 2. If I have y equals 2/3 x, first of all, is that direct variation? Yeah. Let's graph it. Okay, my y-intercept is at 0, always, because there's no plus b on the end, it's just plus 0. What's my slope? So,
2 over 3.
yep, up 2/3. Oh, I missed. Try that again. Closer. All right, graphed. So graphing direct variation equations should be pretty quick because you always put the first point in the origin, 0, 0, and then you just use your slope, graph it, and you're done. Let's do one more. If I have y equals -3x, is that direct variation?
Yeah.
Yes. What's my first graph number? At 0, 0. What's my slope?
Down 3.
Yep, down 3/1. Graphed. Not too bad, right? It'll be a pretty quick lesson for you guys. All right, so now let's look at example 3. And we're going to write a direct variation equation from a graph. All right, so they give you this graph. We know direct variation has to go through the origin. Does this graph go through the origin? Yes, so that's good. So then all we really need to do is find the slope, which in this case is represented by A. So if I can look at this point and going to the next point, I go which way? Down 2/1, right? Somebody say yes.
Yes.
Thank you. So down 2/1 is my slope, which is just -2, right? So this is my direct variation equation. And then for B, this was A, they ask you to find the value of y when x equals 30. So I just take my equation and I plug in 30 wherever the x is. What is 30 times -2?
60.
-60. Solved. Yes, sir. Any questions? Yes. He just needs a minute to write. All right, the last thing we need to go over is the key concept that you should have written in your journal. Okay, this is talking about the properties of graphs when dealing with direct variation equations. When you have a direct variation equation, you always have the line through the origin. We talked about that. And then the slope is A, right? So if you look at this one, when it rises up from left to right, that's a positive slope, and this is telling you that the slope has to be greater than 0 because it's a positive slope. Can't be 0, it has to be greater than 0. When you see this negative slope, then you know that your slope is less than 0 because it's a negative. That's like saying this one would be y equals 2x, whereas this one y equals -1x. Does that make sense? So just when you see the slope, you'll automatically know, okay, this one's rising from left to right, it's going to be a positive number. This one's falling left to right, it's going to be a negative number. Okay, we're going to skip example 4 and go to example 5. Direct variation equation can be rewritten as y over x equals a. Okay, all they did, see the original direct variation equation? All they did is divide the x out. So you get y over x equals a. That's so you can solve for a. Okay? So, looking at example 5. We have a table. The table shows the cost, C, of downloading S songs at an internet music site. So the first thing they want you to do is to explain why C varies directly with A. Okay, so first we need to create our equation, the y equals ax. To do that, we find the slope. To find the slope, we just use these as 2 points. And you can say, this is x, this is y, so I can do y2, which is 4.95, minus y1, 2.97, over x2 minus x1. You guys remember that equation?
What?
Y, to find the slope?
Yeah.
Okay, that's all I'm doing right here. So what's 4.95 minus 2.97?
0.02.
Over 2. So divide that, what do you get? I believe you get 0.99.
Yeah, I don't know if I did the math.
I think you did. Okay, so I can write this direct variation model as y equals 0.99x. In this case, they want us to use s and c. So I would actually change it to c equals 0.99x. Not x, s. Basically, you have figured out that the cost is 99 cents per song. See that? All right, any questions on how to do this? All right, you're going to be doing numbers 3 through 8, and then 26 through 37. No IXL today.